Okay, so what we are going to study in this lecture is solution of homogeneous differential equations. Okay, so in the previous lecture, that was on yesterday, what we have discussed? We have discussed first of all what is the solution of a differential equation, and after that we have discussed how to solve linear differential equations using variable separable method. Okay, so further there are three types: type 1, type 2, type 3. So we have discussed all the three types of variable separable method. So we have covered that part. So now we are going to start a new topic, that is homogeneous differential equations. Again, so if we talk about the previous lecture, what we have discussed? We have discussed solution of differential equations. See, this part remains same. Solution of differential equations. This part remains same for the entire chapter. What do you mean by solution? Solution means finding the value of y. Finding the value of y. Finding the value of y, or we can say finding the function. Finding the function. Okay, because function is there. Okay, initially you will be having a function, and then you will convert that function into a differential equation. So now if someone is saying that you have to solve a differential equation, then what does that mean? That means you are having a differential equation and now you have to do something to bring back the original initial function, right? So these are the 2 points which are very important for solving the differential equation. And we have discussed variable separable method and its type. How many types were there? 3 types were there, right? What were the 3 types? Type 1 was reducible to variable separable, and there were polar coordinates also. Yes, when we have discussed like x dy minus y dx can be written as r cos theta, and so on. So these were the tricks. So now we will not waste much of the time in recall. So we will directly start our new chapter, that is homogeneous differential equation. Oh, sorry, not new chapter, new topic, homogeneous differential equations. Now, what do you mean by homogeneous equations? See, as we can see in the definition, the function x comma y is said to be homogeneous function of degree n if we have f of lambda x comma lambda y is equals to lambda raised to the power n of xy. So I am pretty sure that you guys are not understanding whatever is written in this part. So I'll help you with the example. Okay, first of all, homogeneous means what? So homogeneous means, see, I can tell you by this example, like when you were in class 10th or you were in class 9th, so you might have read about homogeneous mixtures, right? So what do you mean by homogeneous mixture? There were 2 types of mixtures, right? Homogeneous and heterogeneous. Homogeneous, a mixture of sugar and water. A mixture of sugar and water is known as homogeneous, right? Because sugar is entirely dissolved in this water. But if we talk about heterogeneous, so a mixture of sand and water is a heterogeneous mixture. Why sand, right, and water is said to be a heterogeneous mixture? Because we can see that the sand particles cannot be dissolved in water. So sand will be separated. Sand and water can be easily separated. So that is not a homogeneous, that is a heterogeneous. So just like same concept is there in maths also, homogeneous means when x and y are so much involved in a function that they can't be separated easily. They can't be separated easily. Okay, so this is a mixture which we call as homogeneous. So you'll be having terms which are having both x and y. Okay, see for example this. Now this was chemistry, right? This was the idea brought up by chemistry. So I have told you guys, like homogeneous functions are those functions in which x and y both will, a single term x and y both variable could be present, and it's hard to separate them because they are dissolved in entirely. Okay, but if we talk about maths, see, we can see that there are 3 terms. X raised to the power 2 by 3 is there, and in this term both x and y are there, right? And in this term only y is there, and then only x is there. So these, just analyze these 4 terms, sorry, these 3 terms. So if we talk about what is the degree, what is the power of x, so power of x is 2 by 3 in the first term. Power of x is 2 by 3. Power of x in the second term is 1 by 3. Okay, and power of, okay, if I ask you the total power is 2 by 3 here. Okay, here the power is 1 by 3 and the 1 by 3 for x and 1 by 3 for y. So total power is again 2 by 3, right? And y 2 by 3. So since 2 by 3 is the common power. So we can take 2 by 3 as common, right? Like if you just replace your x with lambda x, so what will be happen? Okay, so let me do it properly with the standard method. Okay, just wait. Okay, so trick says replace x with lambda x and y with lambda y. Okay, now if you just replace this in this function, so this will become lambda x raised to the power 2 by 3 plus 2 into lambda x raised to the power 1 by 3 lambda y raised to the power 1 by 3 plus 5 lambda y raised to the power 2 by 3. Alright, this will be the function. Now we can say that lambda raised to the power 2 by 3 into x raised to the power 2 by 3 plus 2 into lambda raised to the power 1 by 3 into lambda raised to the power 1 by 3 into x raised to the power 1 by 3 into y raised to the power 1 by 3 plus 5 into lambda raised to the power 2 by 3 into y raised to the power 2 by 3. This will be the initial function. Now see, can we take lambda raised to the power 2 by 3 as common? Lambda raised to the power 2 by 3 as common, and entirely this is lambda raised to the power 2 by 3. So we can take lambda raised to the power 2 by 3 as common from the entire function, and now we are left with this. So this is nothing just my fx. This is nothing just my, this entire is my fx. This is my fx. So this can be written as lambda raised to the power n fx, right? This can be written like this expression. So yes, it's a homogeneous. So if you are getting into the concept, then you have to check by this standard method that you have to replace your x with your lambda x and replace your y with your lambda y. And if the whole power of lambda is easily taken out as common, then that means that it's a case of homogeneous differential equation. But if you don't want to go that much long, so I will definitely tell you a trick. Okay. And why this is necessary to know about the homogeneous differential equation? Because see, you can be an expert in solving a differential equation, but you may not be that much fine in judging like whether the given differential equation is of homogeneous or of linear or of variable separable. So this thing is very important because you have to first identify what kind of differential equation it is, and then only you can proceed for solving, right? So this is very important to let us know. Okay. So now trick part is just analyze each term and collect the total power. Just analyze each term and collect the total power. Irrespective of x and y, just collect the total power. So total power is 2 by 3. Here the total power is 1 by 3 plus 1 by 3, that is 2 by 3, and here again is 2 by 3. So yes, if the total power is same for each term, the equation is said to be homogeneous. As simple as that. So what was the trick? If the total power of each term is same in each term, then that means it's a case of homogeneous differential equation. Now we will come to the solution of homogeneous differential equation. Okay, so I'll tell you with the help of one example. So as you all can see that this is a question. If a curve y is equals to fx passing through the point 1, 2 is the solution of differential equation. See, this is the differential equation that is given to us. 2x square dy is equals to 2xy plus y square times dx. Okay, and the question is asking you f of 1 by 2. Again, a particular solution is given to you. See, point 1, 2. A particular solution is given to you. Like when x is equals to 1, y is equals to 2. And you have to find the value of y when x is 1 by 2. So when x is equals to 1, y is 2, that we know. This is given in the question itself. Okay, and when x is 1 by 2, we have to find the value. We have to find the value when y is 1 by 2. Okay. Now before starting this differential equation, before starting this solving differential equation, we have to first make sure which type it is. Now obviously this is a lecture of homogeneous differential equation, so you will be saying that yes sir, it's a differential equation, homogeneous differential equation. But how can you say that? See, dy by dx will be, so I'll first bring my dy by dx term. So this will become 2xy plus y square and divided by 2x square. Okay, now just analyze the trick, like whether this is a homogeneous differential equation or not. What is the total power of 2xy? Total power of 2xy is 2. Total power of y square is again 2. Total power of denominator 2x square is again 2. So since all the total powers are homogeneous, so yeah, that means this is a homogeneous differential equation. This is a homogeneous differential equation. So now we know that it's a homogeneous differential equation. Now what is the trick to solve? What is the trick to solve? Trick. So whenever you are dealing with a homogeneous differential equation, always in each and every equation you have to apply the same trick, and the trick says put y is equals to vx. Where put y is equals to vx, where this v will be your variable. This is your variable. Okay. So this is not a constant. Please, everybody, please note that this is not a constant. It's a variable. So when you are putting y is equals to vx, then what will be having? Differentiate it, right? So dy by dx will be. Now since this v is a variable, so we have to apply uv. Okay. So v will be taken out as and then derivative of x will be 1 plus x will be taken out and derivative of v will be dv by dx. You remember implicit? Yeah. So that means this is just v plus x dv by dx. So this is v plus x dv by dx. You have to note this also. V plus x dv by dx. Whenever you are substituting y is equals to vx, you have to substitute dy by dx as v plus x dv by dx. Okay. So now I have to solve this question. So instead of this dy by dx, I will be writing v plus x dv by dx is equals to 2xy. So 2 into x into, instead of y I will write vx, plus instead of y I will write vx whole square, and we have to divide it. We have to divide it by 2x square. So 2x square. Now we are going to solve from this side. Alright, so v plus x dv by dx is, this is 2vx square. This is 2vx square plus v square x square. And if you divide it by 2x square, so we can easily take x square as common and it will cancel, right? It will be cancelled if you just cancel out this x square with this x square. So what we are left with? We are left with v plus x dv by dx is equals to 2 plus v square and divided by 2. Sorry, this is v, right? 2v plus v square upon 2. Now you can take v as common. Yes, fine. So we can write it as v plus x dv by dx is equals to, split this 2 in the denominator. So this will become v plus v square by 2. Got it? So 2v upon 2 will be v only and v square by 2. So this is the, now similarly this v and v will be cancelled. So we are only left with x dv by dx is equals to v square by 2. Now you can easily cross multiply, so this will be dv upon v square. d upon v square is equals to dx upon x and 1 by 2. Right? So now you can integrate on both the sides. So this is just variable separable. Variable separable. From this part we can apply variable separable. Because homogeneous function is now reducible to variable separable, right? So what is the integration of dv upon v square? Integration will be, this is v raised to power minus 2. Minus 2 plus 1 is v raised to power minus 1 upon minus 1. And 1 by 2 will be constant dx by x is log x. No. Log x is not the formula. Dx by x, it is minus 1 by x square. It's minus 1 by x square. Plus c. Yes. Right? What is integration of 1 by x? It can be written as x raised to power minus 1 dx, right? So it will be x raised to power. Wait. I think I am getting confused. Wait. Derivative of log x is 1 by x, no? So integration of 1 by x will be log x. So fine, sorry. 1 by 2 log x. I was writing right. Yeah, this is the answer. Okay, so we can now write this as 1 by v. What was our v? So what is our v? So if we find out the value of v will be y by x. Y by x is v. So what is v inverse? V inverse will be x by y. Got it? V inverse will be x by y. So you can write minus x by y. Just write minus x by y is equals to 1 by 2 log x plus c. This is the entire differential equation. Okay. So tell me, do you have any problem in this? First copy this part. Any problems? Any doubts? Any queries? Not what you are supposed to do? When x was 1, y is 2. So we have to put this solution in order to find the value of c. So minus 1 by 2, it will be 1 by 2 log 1 plus c. Again this term will be 0. So c is minus 1 by 2. Now you have to find f of 1 by 2. So you have to put the value of x to be 1 by 2. So when x is 1 by 2, you have to find y. So minus of 1 by 2 y is equals to 1 by 2 log 1 by 2 plus minus 1 by 2. Okay. So I think we can take minus 1 by 2 as common. So this will be 1 by y, and this will be, if we take 1 by 2 as common, this will become log 1 by 2 minus 1, and this can be cancelled. So minus 1 by y is log 1 by 2 minus 1. So 1 by y can be written as 1 minus log 1 by 2. Okay. So from this you can find the value of y. So let's look at the suitable options. See, log 2 is the only term that they are using. So we have to convert our log 1 by 2 into log 2. So this can be written as 1 by y is equals to 1 minus log 2 raised to the power minus 1. So this will be 1 by y is 1 plus log 2. Right? So y is simply 1 upon 1 plus log 2. This is y. This is the final answer. Y is 1 upon 1 plus log 2. 1 upon 1 plus log 2. Okay, A is the first. A is the answer. See, this was a question from mains 2020. Have you copied this? Let me know so that I can give you one more question. Okay, fine. Done. So everybody let me know. Has everyone completed? Okay. Try this question now on your own. I'm giving you 2 to 3 minutes time. Try and let me know the answer. Has anybody got the answer? dy by dx is given to you as xy upon x square plus y square, right? And this one is a particular solution. y of 1 is equals to 1. Okay, so what is the total power of xy? It is 2 because x is having its power as 1 and y is also having its power as 1. Okay, and in the denominator x square is also having its power as 2 and y square is also having its power as 2. So this is a case of homogeneous differential equation. Now what was the trick? The trick is you have to substitute y is equals to vx. Okay, and then v part is dy by dx will be v plus x dv by dx. Okay, just do the two substitutions. Y is equals to vx and dy by dx is equals to v plus x dv by dx. So this will be like, so this will become v plus x dv by dx is equals to xy. So x into vx divided by x square plus y square. So this will become x square plus vx square. So this is vx square upon vx square divided by x square plus v square x square. So now can we take v square x square as common from the both numerator and denominator? Yes, we can do that. So x square and x square will be cancelled. So we are only left with v plus x dv by dx. V plus x dv by dx is equals to v upon 1 plus v square. Okay. So how to separate now? How to separate the variables now? So x dv by dx can be written as v upon 1 plus v square minus v. This v will be shifted to this side, right? Now you have to take the LCM. So what will be the LCM? LCM will be 1 plus v square only. Now this is v minus v into 1 plus v square. X dv by dx. So this is v minus v square divided by 1 plus v square. And x dv by dx is also there. So this v will get cancelled. Oh sorry, v cube is this. This is v cube, right? Okay, fine. 1 plus v square, v minus v into 1 plus v square minus v cube. Yes, like v cube will be there. Fine. So we are left with x dv by dx is equals to minus v cube upon 1 plus v square. Now do the cross multiplication. So this will be shifted over here, this will be shifted over here. So this will be becoming dx by x, and dv will keep this side only. So we'll keep dv this side only, and 1 plus v square upon v cube minus v cube. Right? Now we can integrate on both the sides. Alright, this is correct, right? Yeah. Now we can apply denominator splitting. So this will become minus 1 by v cube dv and minus v square upon v cube dv is equals to dx by x. So this will be becoming, what is the derivative integration of minus 1 by v cube? This will become v raised power minus 3. So integration will be v raised power minus 3 plus 1 upon minus 3 plus 1. Minus 3 plus 1 is minus 2. So v raised power minus 2 upon minus 2, that means only 2, because minus and minus will get cancelled. Similarly, this is 1 by v only. So this is log v minus log v. 1 by v dv is log v and this is log x similarly, and plus c. Okay. So we can write this as 1 upon 2v square minus log v is equals to log x plus c. Now what was the v? V was y by x. V was y by x. Y is equal to vx now. That means v is y by x every time. So if v is y by x, so this will become 1 upon 2 y square and x square will be in the numerator. This will become x square, right? And minus log y by x is equals to log x plus c. The question is saying that what was the particular solution? Y of 1 is 1. That means x and y both we have to put as 1. So when x is 1 and y is 1, just put these values. So this will become 1 upon 2 minus log 1 is equals to log 1 plus c. So both will get cancelled, this and this, 0 and 0, right? So c is 1 by 2. C we have got as 1 by 2. Now if c is 1 by 2, what is the final differential equation? So x square, this can be written as x square upon 2y square. Now this c is 1 by 2, so we can shift the c as into the left hand side. And this can be written as log x plus log y by x. Alright. So we can do the further calculations as this will be 2y square only. This is x square minus y square. And this can be written as log of x into y by x. That means log y only. Because log x will be log y only. So now whole soul this thing can be written as e raised to the power. It implies that, okay, this much is the differential equation. This was the function. So we can stop over here. Now what was the answer? Like what was the question asking once we have converted this? Y of x is equals to e. Sorry. Then a value of x satisfying y of x is equals to e. Okay, that means you have to find the value of x when the answer y is e. You have to put the value of y as e and get this as, like when y is e, then what is the value of x? This is the question. So just put the value of y to be e. So this will become x square minus e square upon 2e square upon 2e square. And this will be log e base e. So this is 1 only. This is 1 only. So that means x square minus e square is 2e square. Are you getting this? X square minus e square is equals to 2e square. So x square will be 3e square and x will be root 3e. Such an easy question. Such an easy question. Is there any problem? Let me check for the answer also. X is equal to root 3e. Here we are having B. Right? Alright, please copy. From here we have to start, right? Yeah. Rest of the calculations you can do it on your own. Students, please let me know if you are able to write it. Each and every step, each and every line is clearly visible or not. You are writing it or not. In the proper order you are writing it or not. Please let me know. And if there is any kind of confusion, any kind of query, you can ask me. I can tell you the exact question twice or thrice. You can ask me multiple times. Because this is the thing that we have to do. Right? You have to practice so many questions, but how will you practice if you are not knowing the concept, right? I can help you in the concept. In rest you can do it on your own. Let me know once you are done, guys, quickly in the chat. Have you done? Let me know, everybody. Have you written? Completed the whole solution? Completed. Is there anyone else who is still writing the solution? Completed. Okay. So now the new topic, reducible to homogeneous differential equations. So now we will be discussing the equations that are reducible to homogeneous differential equations. So this we will start after a short break. Okay. So I'm giving you a break of 10 minutes. We'll be back after 10 minutes. Okay, everyone. The break is over. The class is resumed now. quickly turn back on your cameras. Yes, so now we are going to not appearing to be homogeneous, but yes, they can be converted into homogeneous. So what is the term that we use? We use equations reducible to homogeneous. Got it? Equations reducible to homogeneous differential equations. Okay. So if you guys remember, in the last lecture, in the previous lecture, I have discussed this type 2 of variable separable, where I was asking the coefficient of x in the numerator and coefficient of y in the denominator should add up to 0. You guys remember this thing? See. Okay, let's take this case now. Dy by dx is equals to ax plus by plus c, and ax plus by plus c. This is a differential equation. Now, if b plus a adds up to 0, so then we can use the trick that we have discussed in the previous lecture. What was the trick? Type 2 of variable separable method. So the trick that was discussed in the type 2 question of variable separable method, that can be used in this case also, but only if b plus a adds up to 0. Got it? But what if b plus a is not equal to 0? When b plus a is not equal to 0, or like in any, you are seeing that b plus a is adding up to 0, then you can use the type 2 of variable separable method. But if this is not the case, like you are not getting 0 when you are adding b and a, then you can use this method. So this method can be useful in first case also and in second case also. So I can say that this is the case for all the, this is the trick for all the cases. Okay, so that's the ultimate standard solution that I am giving to you. So you have to substitute your x, small x, as capital X plus h, and you have to substitute small y as capital Y plus k. Okay, please note that this x is again a variable and this y is again a variable, where h and k are constant. Okay, please note this thing. These are the substitutions that you are going to make. Okay, should we start question directly? Alright, see how we are going to do this. So dy by dx is 2x minus y plus 1 divided by x minus 2y minus 1. Okay, so I'll give you a trick also, like I have to replace my x. I have to replace my x and y. This x should be replaced with capital X plus h, right? And this y should be replaced as capital Y plus h plus k, right? So when you do this, so everything will be changed, right? But dy by dx will be same. Dy by dx will be same as d capital Y upon d capital X. Okay. Now what to write in this case? What will be there in this case? So what we have to do is, okay, so I'll give you one trick. Just replace your x and y. Just replace your x and y with capital X and capital Y. So this will become 2 capital X minus capital Y divided by capital X minus 2y. 2 capital Y, sorry. Okay. So just replace your small x and small y with capital X and capital Y. Okay. And what about h and k? How to find the values of h and k? Okay. So just put the value of h in place of x and put the value of k in place of y. So this will be there will be two equations, right? See, what we are going to do is just put the value of x to be h. So 2h minus k plus 1, and then second equation is h minus 2k minus 1 is 0 and is 0. So, okay, so if you solve these two equations, So h will be your minus 1 and k will be your minus 1. Just put the value of h to be minus 1. So minus 2 plus 1 is minus 1. See, we are getting 0. And again minus 1 plus 2 minus 1. Again 0. So we have got the values, right? So what is the trick? What is the trick involved here? The trick is whenever you are seeing this kind of question, okay, in which it's a case of linear by linear. So what you're supposed to do is, first of all, just replace your dy by dx with capital Dy by capital Dx. Okay. And replace your x and y with capital X and capital Y. So this will become 2x minus y upon x minus 2y. Okay. And now you have to find the value of h and k. You have to find the value of h and k. So how you are going to find the value of h and k? So you can replace your x with h and replace your y with k, and put the entire numerator to be 0 and put the entire denominator to be 0. So when you solve the system, your values will be h and k will be minus 1. So now since we are having the value of h and k as minus 1, so that means this x can be written as, this x can be written as capital X minus, plus minus 1. And this y is capital Y minus plus minus 1 here. So it implies that x plus 1 is the value of capital X. And the value of y, capital Y, will be y plus 1. So just plug in the values again and it will be dy by dx is equals to 2x plus 2 2x plus 2 minus y minus 1 and divided by x plus 1 minus 2y minus 2. Okay, so in this manner you can solve this entire differential equation. Note it down. Have you completed this? So what are the 2 points that I told you? In case of this, you have to replace your small x with capital X plus h and small y with capital Y plus k. And you have to find the value of h and k by putting the values. Okay. So we'll see if any question in the class assessment is from this concept. Okay. Alright. So this is the question. Again, you have to count the total power of each term. So power of x cube is 3. Again, it is 3x square dx plus y cube and then 3x square y dy. Solve these questions and let me know the answer in the chat. Has anyone got the answer for this question? No, sir. Why? See. So how we are supposed to solve this? So x cube plus 3x square dx plus y cube plus 3x square y dy is equals to 0. So first we have to check whether this is a question from homogeneous differential equation or not. Okay. See. So power of x is 3. But here the power of x is 2 only. I think there is a typing error in this question. Okay. Wait, let me check. Okay, x cube minus 3xy square should be there. Okay, this is the question. Okay, please note down everybody, this is the correction. So x cube minus 3xy square dx will be there. And if we shift this term to the right hand side, it will become y cube minus 3x square y dy. Yes, now you have to start solving from this. Okay. So just discard this question. Okay. So start solving from here. Here the power is 3. The power of x cube is 3. And the total power in the second term is also 3. Right? Similarly, in case of y cube, the power is 3 and the total power is also 3. So what we have to do? Again, we have to follow just 2 steps. Y is equals to Vx and dy by dx is equals to V plus x dv by dx. Okay, these two are the substitutions that you have to make. Y is equals to Vx and dy by dx is equals to. So before applying these substitutions, you have to find the value of dy by dx first, right? So we have to find the value of dy by dx. So what will be the value of dy by dx? If you shift this term to the right hand side, it will become x cube minus 3xy square and divided by y cube minus y cube minus 3x square y. Yes. Now start solving. Put y is equals to Vx and replace the value of dy by dx with V plus x dv by dx. Quickly do this now. Has everyone got the answer? Tell me who are doing this question right now and who have done this. If they are done, just let me know the answer for this question. Otherwise, we will skip to the next question. Alright, no response. That means I will just skip this question. Now try this. Dy by dx is equals to y by x plus tan y by x. It's a very simple question, right? Y is equals to vx. When you put y is equals to vx, dy by dx will be v plus x dv by dx. V plus x dv by dx. So v plus x dv by dx is equals to y by x. Now y is vx. Vx by x will be v only. Plus tan v only. Because y by x is v only. Okay? So this v and v can be cancelled. It's a very simple question. X dv by dx can be written as tan v. So dv cot v dv. Cot v dv can be written as dx by x. Got it? So now you can integrate on both sides. What is the integration of cot v? Tell me the integration of cot x. Integration of cot x is log sin x. Log sin x. So log mod sin x. Sin v I must write. First of all, it is log x. Now see, if you are having the full equation in terms of log, for example, in the left hand side there is only one term, that is log. In the right hand side there are two terms. First one is log x. So now you are taking the constant only. So you can take this constant as log c. So instead of taking the constant as c, you can take the constant as log c. So now whole equation can be solved. Okay, so now what was v? V was y by x. So log sin y by x is equal to log x plus log c. Or we can write it as sin y by x is equal to xc. This is the answer. So we have converted it into a single log. Log x plus log c can be better written as log xc. And here we are having log sin y by x. So both the logs can be, we can equate both the logs. Students, I would like to ask one question. Are you guys seriously, you are not having any kind of doubts? Everything is clear? Each and every question that I am bringing up over here, this is cleared, right? Fine, we can solve this question now. Solve x dy minus y dx equals to root x square plus y square dx. Try and let me know the answer in the chat. can we just divide the whole equation with dx? So this will be x dy by dx minus y is equal to root x square plus y square. Okay. There is another typing error. This is not root x square plus y square. It is only x square plus y square. So this one is only x square plus y square. Try to solve it now. Put y is equal to vx and dy by dx as v plus x dv by dx. These two substitutions you are supposed to do. So x multiplied by v plus x dv by dx. Got it? Minus vx will be equal to x square plus v square x square. This is vx plus x square dv by dx minus vx is equal to x square plus v square x square. So vx and vx will be cancelled. So this can be written as x square into dv by dx is equals to, we can take x square as common, so this will become 1 plus v square also. So again this x square and x square get cancelled. So it implies that dv by dx is 1 plus v square. So that means dv upon 1 plus v square is equals to dx. Now we can integrate on both the sides. So what is the integration of 1 upon 1 plus v square? Tan inverse v is equals to x plus c. Or we can say that tan inverse y by x plus c. So this is supposed to be the final answer. Quickly note it down. Minus 1 by y is equals to x. This is what? Minus 1 by y is equals to x is what? Kaya, you were trying to say something? Is this question now clear to you? Okay, alright. Sorry sir, I left plus 1. Minus 1 by v is equals to x plus 1. Fine. So there is one very interesting question after that. So just let me know once you are done. So I'll give it to you to solve. All of you present over here, just let me know whether it is completed or not. In case of any doubts, query, just ask me. See, this one is very easy topic, homogeneous, right? It is very important for CBSE, not for JEE mains. Only, I think, a very few questions are there in JEE mains from this topic. But in CBSE, it is very important. Because see, this is very lengthy. The question that you are solving, the procedure is very lengthy, right? So JEE will never ask such kind of lengthy questions. Alright, just give me a good to go so that I can give you one more question. and that you have to solve it on your own completely. Done? Fine. Solve this now. Okay, I want answers from all of you. Everybody. Kayal, Sudarshan, Vishwanath, Shrutika, Pavan and Dhaneshwar. Pavan and Dhaneshwar, quickly turn on your cameras. I want answers from each one of you. Okay, try to solve this. So option C you are saying? All of you has completed? Everybody is saying option C. Vishwanath is saying B. Okay, so there is a catch in this question. C. So I've told you, you have to put y is equals to vx. Okay? And then dy by dx can be replaced with v plus x dv by dx. Got it? But what if the question can be easily converted into dx by dy form? Like either you have to do this thing, or you can write x as equals to vy. And then dx by dy can be written as v plus x dy by dx. Oh, sorry, dv by dy. So just look at the question. The question is in the form of x by y, not y by x. So this is favorable if the y is taking the form y by x. But this is favorable if you take the question is taking x by y form. So our question is in x by y form, right? See, this is x by y. This is x by y. This is x by y. Again, this is x by y. So you can do second this, like this is the first thing and this is the second thing. So you should go with option number 2. X is equals to vy and dx by dy is equals to v plus x dv by dx. Now tell me, is anybody is there like who has used second option? Okay. Now I will solve this question. So when I am putting x is equals to vy, that means x by y is v. So this can be written as 1 plus e raised to the power v. Okay. Dx is right now dx only, and then plus e raised to the power again v into 1 minus v and into dy is equals to 0. Now rather creating dy by dx, I should create dx by dy because I have to put the value of dx by dy, right? So just divide the whole equation with dy. So this will become 1 plus e raised to the power v into dx by dy plus e raised to the power v minus v into e raised to the power v is equals to 0. Got it? Now what is the value of dx by dy? V plus x dv by dy. Okay, wait. Not 3 plus x dv by dy. See, you can do this thing again, right? You can do this thing, do this thing over here again. Yeah. So your v is variable. So when v is taken out, so it will be dy by dv. dy by dv. No, you are differentiating with respect to y only. Sorry, my bad. You are differentiating with respect to y only, right? So v is the variable, so you have to take it out. Okay. And what is the derivative of y? It will be 1 only. Plus, then y will be written. Okay, then y will be written and it will be dv by dy. This is the case. So, what is the value again? V plus y dv by dy. V plus y dv by dy. This whole thing multiplied by 1 plus ev. And plus e raised power v minus v into e raised power v equals to 0. So this is the case. So this is 1 plus y dv by dy plus v into e raised power v plus y into e raised to the power v into dv by dy plus e raised power v minus v into e raised power v is equals to 0. Now how many terms will get cancelled? How many terms will get cancelled? This will be cancelled with this term. Yeah, only this term. So rest of the terms we can shift into the right hand side. Yes? From here, what are the remaining terms? See, y dv by dy we can write over here. Plus y into e raised per v dv by dy. We can write. And plus e raised per v is there. And plus v is there. Only these 4 terms are there. Okay? Yeah, only these 4 terms are there. So it can be written as e raised per v minus v y dv by dy plus y into e raised per v dv by dy. Right? So now from here you can separate the variable. Alright? From here you can easily separate the variable. Everybody got this? Completed this part? See, these are the substitutions that will make your question easy. Okay, that will take less time to complete. Alright, try this one also. Try this and let me know the answer in the chat. Have you completed this? Completed everybody? Again, how to solve this question? X square minus y square. dx minus xy dy is equals to 0. So x square minus y square minus xy dy by dx is equals to 0. Okay. So put y is equals to vx. So dy by dx can be replaced with v plus x dv by dx. That's it. And it will be all. You will be able to solve the question. Again, I'll help you with this. X square minus v square x square can be written over here. And it can be written as x into, instead of y, you have to write x into vx. And instead of dy by dx, I'll write v plus x dv by dx. So x square can be taken out as common. It will become 1 minus v square. Here x square into v square is there. And then here you can write x square see vx you have to write. Yeah, so this will become x cube. Yeah, x cube v dv by dx. Alright, so x square into 1 minus v square, and again you can take x square as common, so this will become v square plus x into v dv by dx. And then you can solve this question on your own. Okay.